Okay, it's Monday morning again. In this particular episode, I've got some little video clips and stuff in addition to other things. And we're gonna. So I like to touch one of the things I used to get confused about when I first started teaching as a professional instructor was I had the idea that if I told the students something once, that was the only time they needed to hear it. But the thing about it is, you never know what they're getting and what they're not getting until you go out there and you find out that something you told them they totally ignored. Like for example, I was teaching brakes. I may have mentioned this before. I don't know. You know, I've been talking so much on here, you're probably going to hear me repeat myself. But I told some of my students, the first group I taught, the first semester I ever taught, back in 2001, I was teaching brakes. And the first thing I cautioned my students about is I says, don't ever use compressed air to blow brake dust off because it gets in your lungs and all that. And it's a terrible mess, you know, it just messes you up something awful, your lungs wise. And the very first time the guy stepped out in the shop, first thing he did, he pulled a brake drum off of one that had high mileage, a lot of dust on the brakes, and he blew that dust off with the air hose. And I had very plainly said that not 15 minutes earlier in the classroom. So anyway, sometimes if you hear me repeat myself, it's, you know, the one teacher I heard about one time said, we throw mud up against the wall and see how much of it will stick. That's what teaching is like. You just keep, you know, saying it and hoping they'll get it. And I know that sometimes I need to hear something 2 or 3 times before I get it, and there's nothing wrong with having a little bit more of a repeat every now and then. This here's the mass airflow sensor. Some of them have got a screen like that, but a growing number of them do not. My Explorer that I drive now does not have a screen in front of the mass airflow sensor like this one. And now this screen right here would work pretty good to keep spiders and stuff from getting up in there and building little nests in this place where the air is supposed to go through there. And that's a close-up of that. There's these 2 wires in there. This one of the wires is a platinum wire that is heated to a certain temperature above the other wire, which is basically just a thermistor that's used to measure the temperature of the incoming air. So the more it has to heat the hot wire to keep it at a, let's say 300 degrees Celsius or whatever the magic temperature is above that cold wire, it uses that, it interpolates that as the amount of air that's going into the engine. Is calibrated to recognize that. Now, whenever these wires get really nasty like these right here, it can cause them to be sluggish and stumble and that kind of thing because it just doesn't report properly when it's got that kind of crud on it. And I took a picture of one that I had in the shop like that. Alright, so this is kind of the way this works. You got this little bridge here, and you got a thermistor right there, and then you got this little gate, you know, and there's a transistor here that's feeding voltage in here. And that output voltage is basically the amount of current it takes to keep this wire hot is what determines what that output voltage is. You know, it could take a long time trying to explain that electronics aspect of that, and I'd probably get it wrong. But you can read these words up here if you want to pause the slide and look at that. But you got a hot wire and then you got a thermistor wire. And that's why you got those 2 wires, and one of them, they put this one below that one so that the heat that's coming off of this one won't heat that one up, see? So basically you got a air temperature sensor right here that's built in, and sometimes they use that piece of information well, sometimes they'll have a separate thermistor for the intake air temperature sensor. Sometimes they'll just get it from here. And they also use this information on some of these, some kind of way to give you barometric pressure readings and that kind of thing, which is, you know, rather than having a MAP or a MAF airflow sensor, in other words, a MAP sensor gives you barometric pressure when you first turn on the key, and then when you start it, it starts reading manifold absolute pressure. But these right here, sometimes this sensor here will actually give you barometric pressure. Somebody else might be able to explain that better than me. I know that that's how it works, but I'm going to move on to the next slide. Now this right here was a situation where I was looking at a charging system. This is not really enough voltage. However, when the battery's not fully charged, that voltage is going to be low. Now we got some crummy connections there too coming off the car. But you notice how this is bouncing above and below, and this keeps saying good, bad, good, bad, good, bad, and that's just not really enough. That alternator there was one that I didn't trust, and I always kind of like to see 14.5 volts here and I like to see that, you know, the closer the battery voltage gets to the target that the regulator or the PCM or whatever's controlling it is looking for, the lower this amperage goes. This amperage should have been higher than this, and it shouldn't have been bouncing back and forth between negative and positive. So, and this little LED that they use to tell you if you've got a good or a bad stator, I never have been able to trust those personally on any of the ones I've used. We had a Mac that we used when our VAT 40 finally died, the one with the needles. It was so good, you could never fool that one. If it told you the stator was bad on that alternator, you could take it to the bank if that needle was in the bad stator area, and there was no way you could fool that thing. Now these with the lights on them, for some strange reason, they just go kind of wacky, and sometimes you may just have a bad battery or a weak battery, and it'll turn that light on and tell you the stator's bad, or that's the Mac tool would do that. This one here tended to bounce around all over the place. And so, you know, of course, I like this machine here because it's got a load control knob on it. It doesn't do everything automatically for you. And whenever you turn that knob, this right here, if you got that thing to, you know, to your load, it would tell you when 15 seconds had passed, so that, because what you're supposed to do is go to half of your cold cranking amps and hold it there for 15 seconds to see if the voltage dropped below 9.6 volts. And that carbon pile would really start to, you know, it's a bunch of stacked carbon discs that you tighten them together when you're turning that knob. And of course you also could hook a regular compare voltmeter leads in here and you put external, and you could use this box here for a voltmeter, which I almost never did that, you know. But there you had this 0 button right here too, and then you could freeze your reading so that you could just look at it and study it. This right here is supposed to be telling you about the diodes, right? Okay, now this one right here is another one I tested. And this alternator was really noisy. I don't have it where you can hear the noise on here, but it was just whining up a storm. Usually when it whines, it's kind of like a ceiling fan, you know, it's got a magnetic resonance going on. This one here had what looked like good readings right here, and see, whenever I loaded it, it came up to like 60 amps. And it was, because when you load it, you're pulling that voltage down, and that's going to cause it to try to meet that demand. But I was worried about that noise, and I came over here to this picoscope that I had hooked up, and it was giving me what looked like a fairly normal alternator ripple. Now it did have some ripples in the ripple, you know, which I didn't really see that as significant. But I went over so you could hear the noise, and that thing was going. Rrr. Now there are bearings in an alternator, and the bearings can make it go bad too, and the bearings can cause a resonance through the case that can cause crazy stuff to go on, like this right here, you know. There's this sort of a ripply thing like that, but you can see how it would go down and up. Usually that's a lot flatter than that, but I don't see anything wrong with these ripples. Now whenever I would see some where the ripples were just all over the screen and real ragged, that's the ones that I would use. And I would, whenever I like to take a scope and connect it and look at the stator and compare that to what it's telling me. Now this BT608 that I've got, this Altel thing, it does a tremendous job of checking the thing and giving you a ripple, and it goes through all kinds of steps, and you can pretty well trust that one. And this is a little story about this 135 DKB Waukesha engine. My dad had put in a sawmill when he was 52 years old, and he ran it for 10 years until he decided to, you know, go ahead and retire and help my mom with her flowers and all. But the point is, when he put the sawmill in place, but he didn't have an engine. And so he came to visit me in Texas, and this 135 DKB Waukesha engine was a 1957 model, and it was on a barge down there that we were using to pump fuel, and that they had to get a fuel pump spur for it, which is a little rubber thing that goes between the drive and the fuel pump. And it was really, really hard to get that fuel pump spur, and so then the engine started misfiring. And my supervisor says, well, we don't need to try to fix this one old 1957 model engine. Now this was in like 1981 or 82. He says, what we need to do is go ahead and replace it with a 671 Detroit. And so he put a 671 Detroit on there, and they set this one out there by the fence. And that was a new one like this, you know, that's been refurbished or whatever. And put it out there by the fence. And there was a guy that was working there that was going to diesel mechanic school at night over in Beaumont, Texas, and he and the supervisor, my supervisor, said, told him, he says, you can have that engine if you want to take it over to the school, so, you know, for y'all to work on, because it's, and he said he even had a workshop manual for it. And so that thing sat out there in the rain by the fence behind the shop for like 3 months with it raining on it. That boy never did take it, never did take any initiative to take it to the school or anything else. Well, my dad came down there and he was talking about needing an engine for his sawmill, and I said, well, why don't we go look at that engine down there at the plant? So we drove the 15 miles from where I lived in Port Arthur. I lived at 3924 Lakeshore Drive, Port Arthur, Texas. You can actually look at a house up online if you want to. But anyway, I drove from Port Arthur. We went down to Sabine Pass to Sabine Offshore Services where I worked, and doing fleet maintenance. And he looked at that engine, and we were on my pickup when we went down there, and he said, can we put that engine on your truck? And I said, yeah, we can do that. And so we put it on the truck, and I hauled it back to my house, and I told my supervisor the following Monday that I had taken the engine home, and he gave me the shop manual to go with it. Interestingly enough, that thing had a copper head gasket that was reusable. You know, when you pull the head off, you could just clean the gasket off and put it all back together with that same gasket. Peculiar stuff. But my dad had to come back to Alabama, you know, at the time, and that thing was down there under my carport for a while. And in the meantime, when we got it now, it did not have a power takeoff, and it had no starter, and there was no battery. And so I started scrambling around looking for stuff for it, and I managed to get this power takeoff, and I got, but now you might notice that power takeoff was made for some other engine. It wasn't made for this one. And the power takeoff that had been on this one, they put on the 671 Detroit. All right, and you notice how that flywheel is sunk in right there. All right, and so this had a clutch, just kind of like a clutch on your car, but you engaged it, disengaged it with this lever. And so that would basically turn the, you know, put the power out to the belts and all whenever you lock that clutch in. Well, I built a plate to bolt in here to flatten that out so that clutch, I mean, it was a thick half-inch plate, and I drilled it and I countersunk it, and I put screws in there into these holes, and I buckle that plate up in there. And then I got a circle burner and put it on the torch, and I cut out this adapter plate that I put, you know, bolts around the inside. It had to be, you know, centered and everything. It was tricky to do, but anyway, I managed to make this power takeoff fit that engine, and it worked really well. I mean, he used that thing for years. The cool thing about that 135 DKB Waukesha was that he could saw with that sawmill all day long with just 10 gallons of diesel. It got really good fuel economy. But whenever, let me back up a little bit before I got the power takeoff. I got a starter. It was a Lee Neville starter. I did a lot of business with Spence Battery down there in Port Arthur. And I told David Hughes, I said, I need a starter for this thing. And he said, well, I'll tell you what. He said, I don't like Lee Neville stuff. And he said, I got a bunch of Lee Neville parts on hand. And he said, I'll just have Oliver back there in the shop build you a Lee Neville starter for that thing. Because it was like I think the designation for the Delco starter is a 40 MT or something like that. And so he built me the big Lee Neville starter, brand new one. Put it all back, because he had all in part. He just didn't like those Lee Nevilles, and he would always take the Lee Neville out of service and replace it with a 40 MT Delco, and he never wanted to sell anybody a Lee Neville anything. So anyway, I got that Lee Neville starter, and I laid it on the ground. I got the bolts that was, you know, you could bolt it up with and all that, and I had it laying there next to the engine. And I got a battery he had. It was an 8D battery, great big old battery, that somebody had damaged the case on it with a forklift, and he had basically patched it some kind of way. And we put new acid in it and all that. It was a brand new battery. So I had a battery and I had a starter, and my dad came back down there for a visit, and whenever I showed him the battery and the starter and all that, and he had some tools with him and everything, I went to work and left him there with that motor by himself at my house. And when I come home that night, or that afternoon, he had that thing under the carport running. He had a bucket of diesel there, and he had a hose sticking in it, and it was, but what we found out was it was misfiring on cylinder number 2 because it had a busted push rod. And so we got one of the other push rods out of there and got the little top where the little, you know, adjustment screw went down in this socket thing on there. And I managed to put that on a piece of threaded rod that I've cut the same size, because I had a drill press and everything in my little utility room shop. And we built a push rod for that thing. But that's why it was skipping, and that's why the engine was taken out of service, because he didn't know what was wrong with it. Nobody never even checked it. So we built a push rod, adjusted the valve, and that thing ran like a brand new engine. He used it for years down there on his sawmill. Anyway, that was basically a free engine, but it took a lot of work to get it going. And that's a picture of Dad out there operating the engine. Another funny story, that Leesonville starter solenoid failed. And it got to the point to where you had to turn the switch to throw the starter in, but it wouldn't make the connection between here. So you had to have a screwdriver on hand to short these terminals together while you had this switch clicked over here to throw it in, so that the electromagnet would kick the starter drive in, but it wouldn't make the connection to run the starter. And I shorted that with a screwdriver. Every time I shorted that with a screwdriver to spin that starter and make that screwdriver red hot. And one time I wasn't thinking about what I was doing, and I put that red hot screwdriver in my back pocket, burned a hole in my pocket, made a burn on the back of my leg and everything else. It didn't take me long to jerk it back out of there, I'll tell you that. But anyway, this is MultiStrike ignition, and you're going to see this on a lot of vehicles. Since the early 90s, Ford's been doing it on like Ford Escorts. You know, they had the old EDIS system, and a lot of them, they would actually pop the spark 3 times when it was idling. Now, back when the Tempo was out there, there were some of those that had a little random misfire at idle, and we were told to open the spark plug gap up a little bit on all those cars, take care of that problem, and it took care of it. And so here was the little bit of shot I got from my Explorer. This is not a triple strike, this is a double strike, but you might notice this grid, this radical, is 1 millisecond this way and 5 kilovolts that way. And so these are actually popping, you know, a little over a millisecond between fires. They did that for better burn, okay? And that's another reason they do this. Now, when you crack the throttle, this MultiStrike goes away. Crown Victoria, I'm going to be doing a job on my dad's, well, it's actually a Grand Marquis. His 01 Grand Marquis started misfiring whenever we were driving into this, to one of his appointments the other day, and it's a long drive, like 30 miles each way. And I was thinking, that's really cool, because I'll be able to, you know, do a video on that whenever I get time after Christmas. I'm going to make that happen and show you guys, you know, what I find on that. It's probably going to be a bad cop call. But anyway, we'll get to work on that. Okay, so incidentally, when talking about cop calls, and well, let's back up before we talk about cop calls. This VECI decal was for years under the hood, and a lot of the times you'll still see this. But this gives you all of your vacuum routing diagrams. Now, the ones back in the late 70s, when they still had some carburetors on some of the F-150s and stuff, that thing looked like a road map of Clarksburg, West Virginia. Some of you guys, your older guys, might remember that. And they would put little hard plastic lines in there, and those things would break, and we'd have to fix all that stuff. Or the engine mechanics would put an engine in there, and then they didn't want to have the fool with putting all them vacuum lines on there. And so the service manager would give me the vehicle that they had put the engine in, and I'd have to put all these vacuum lines back on here so that this thing would be like it was supposed to be. But let's look down here. If you look at this right here, the spark plug tells you which spark plug goes in it. Pretty cool. The gap, now this is on the 96 model, if you remember this. If you look over here, it says 96, you know. This is USCP and California regulations, the 1996 model year. Okay, so 52 to 56. Now the older ones, like the late 80s vans, like 302 and 351, their spec on that thing was 42 to 46 thousandths of an inch. Anytime I put spark plugs, drawing on what I learned from those Tempos, anytime I put spark plugs in one of those vans, I always set the plugs on 50 thousandths of an inch, because it just made sense to do that. Because if the spark is just a little bit, if the gap's a little bit wider on a new plug, it's going to pop hotter, and it's going to fire with no misfires. My buddy Donnie was over there, and he had just come from the Lincoln dealership up there to come to work for us at Ford, and he didn't do vans up there. And I told him when he's putting plugs in one of them vans, I said, you need to gap those things at 50 thousandths of an inch. And he said, no, this sticker says 42 to 46, and I'm going to put them right between there, about 44. So he did, and it had a random misfire. And he had to pull every one of those plugs back out of there and gap them out to 50 to stop that that random misfire and all that. So Here we've got the gap 52 to 56, which I like that. I used to put mine on 50, you know, use one of them ramp gauges and all that. And then right here, this is three-way catalyst, and it says there's two catalytic converters, and this is air injection reactor. It's got an AIR system on it for, you know, upstream air and all that kind of thing, and to help the catalyst. It's got two oxygen sensors, and it's got EGR, and it's sequential fuel injection. You can, you know, unpack this stuff if you just think about it and what you're looking at. And there was also a calibration sticker that had a little number on it. I was going to put that up here. There's a, on the shock tower on some of these cars, there's a tear tag that came off the engine controller that would help you identify the engine controller. Now, the Ford copper coil stress test, I talked about this and I touched on it a little bit the other day. These are some screens I took pictures of. And these are the kind of coils I'm talking about. These are the kind of coils my dad's Grand Marquis has on it. It's an 01 model. But the Ford copper coil stress test worked like this. I wish I had a better picture of that. But you turn the coil upside down and make sure that it cannot jump through that boot and hit anything else. It's got to be standing straight up in the air. This is counterintuitive to somebody that's used to these high energy ignition systems. But if you put that coil upside down and you put your lead on it, going over here to your scope, now you have on the IDS, you had to just select coil stress test. But you can actually do this with your scope if you play with it a little bit and get. But a good one will look like this. That's what a good one looks like when it fires. And one that's bad is going to look like some derivative of this. It will not look like that, but that is a perfect example of a really good one. Sometimes you'll see this will be a little wider and the ramp will look slightly different. But that's what a good one looks like. That's what a bad one looks like. And you've got a little inductive probe that's just clamped onto the top of the copper coil, and it's basically reading inductively that right there. That's good, that's bad. You could also just put one of these on there. If you know, these cost about $18, $20 a piece online. And the first time I ever saw one of these was when I went to General Motors School in 1981. Ellen Smith was showing us one of these, and I bought one. But anyhow, that little spark tester right there hooks to ground. You can hook that thing to ground and put it in that coil, and whenever you crank it up, if it won't fire, you know that coil's a bad one. You just move it from one coil to the next. If you wanted to be a smart aleck and you wanted to spend a lot of money, you could buy 8 of these, or 10 if you were going to be working on those 6.8 liter Fords, and you can put one in each plug, ground them all, and have somebody spin it over while you watch, and you can immediately pick out the bad coil. And you know how those doggone coils do. They go poo, 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 poo. You know, it's the ignition misfires and all that. I always wonder when I see one sitting out here. I took this picture the other day. It's a beautiful little MG sitting out there on the median. Nobody around. Cars going by. Now, in this part of the country, nobody strips cars. You know what I mean? So if you did something like this in some of your big cities, you know, that car wouldn't be there 3 hours before somebody had the wheels off of it and the engine, you know, parts junk. You know, they'd strip it when they wanted or vandalize it. This one right here was just sitting there in the middle of the median, and I wonder what broke that car down. Why is it sitting there? Who left it there? Did they run out of gas? Did something else go wrong with it? You never can tell. That's just a little interesting thing. I always wondered about that. Now, on those late 80s trucks, you might remember this little actuator right here on there that's, you know, moves the ignition switch. Those things like to break. And whenever they break, if you know how to put one of those in there, it's not very difficult. If you've done 2 or 3 of them, there's the ignition switch hanging down there. I got this one here that somebody brought, where the guy had tried to fix it himself, and boy, he stripped that thing down. He brought all them parts just thrown in a bucket in there, and there's the steering column where he had taken it apart from down in there. Anyway, don't you just love to get somebody to bring one in there? You got to put all that nonsense back together. Anyway, I got that taken care of. My son's truck right now has got one of these that's broke. He's got a bunch of vehicles, but one of his is a F-150 that's like it's a 91 model, and he actually has to reach down in there with a pair of pliers and push on that little rod to move the ignition switch to start the vehicle. But now you can build a back pressure testing tool. You can one of these little bungs right here. You can go on Amazon and you can buy these little 18 millimeter metric 18 by 1.5 oxygen sensor plugs, and it's a bung for the exhaust pipe where you'd put in there, you know, if you had some kind of a off-road vehicle you weren't going to use, it didn't have to pass emission testing, and you wanted to stop up that O2 hole, but you didn't want an oxygen sensor in there, you'd screw this in there. That is the perfect size for, and that's also the same size as the big spark plugs that used to be on some of the Ford straight 6s, you know, 18 millimeter spark plugs. Now, I mean, the thread part would be 18 millimeter. Get you a bleeder screw. And this one right here is a front disc caliper bleeder valve. You can buy those on Amazon too. All right, and then what you're going to do is you're going to take that bleeder valve, and this is a cutaway of it. I'm just showing you that this is drilled all the way down here, and then there's a hole in the side. What you're going to do is you're going to cut that off, hacksaw that off, or use your high-speed cutter or whatever, and then drill a hole all the way through this. And whenever you drill a hole, I'm talking about you drill a hole all the way through, and you're going to basically take the right thread tap that's going to match up with the threads on here, and then you're going to tap threads in there and screw that in there. And so then you're going to wind up with something that looks like this. This is how I built this one. It's just like I described to you. And this vacuum gauge right here costs less than $20. It's actually a vacuum and pressure gauge. It'll read either one. It'll read pressure or vacuum depending on what you have there. And then this, you can hook that up to that tool that you made down there where the oxygen sensor went. And this is one we found that was reading bad. This is not the same vehicle, but it's hooked up the same way. And we found exhaust back pressure like this. So whenever you give it the gas, it would come way down here. It's not supposed to have any back pressure. If it's a really free-flowing exhaust system, it'll be right here. And even with a catalytic converter in there, it's got practically no back pressure at all. And this one here had back pressure. And so we basically wound up having to put a converter on that one. But that's how we did that. The little tool I built, you see the hose going there? Now I will tell you this, if you're going to be checking one and it's really, really hot and all, what I would do is I would use some of that orange silicone hose that's really heat resistant, because this kind of hose right here doesn't respond well to that, to the heat. You might think, well, there's no heat going through there anyway because this is completely stopped up, but it will get hot and split down there. If your test is going to take longer than a little bit. It seems like you'd know immediately, but I'm telling you, you need to use some hose that's higher temperature than a regular vacuum hose for that. Sometimes you'll see a bent and bridged plug. That one, obviously something got against it and bumped it. It could be chunks of carbon in the cylinder that the piston rammed up against it, because you got a whole lot of deposits on here from oil and valve stems and all that kind of stuff. And if it goes down enough, I've seen those things though where the plug looked just fine, but some little something would get in there and bridge the electrodes, and it would not fire. That cylinder would not fire. On a lawnmower, I've seen this. My neighbor's lawnmower, one time I went over to look at her lawnmower next door, and her lawnmower wouldn't start, and I got some gas on a paper towel and stuck it in the, I checked spark first. It had spark. Gas on a paper towel, and I put it in the carburetor, and it fired up. And then when the gas dried out of the paper towel, I went, well, you got a carburetor problem. And so I found out some of the O-rings in her carburetor had deteriorated. I replaced the carburetor, the $30 carburetor I ordered online, popped it on there, and it ran real good. The following week, the darn thing wouldn't start again, but this time it wasn't gas. The spark plug was bridged. Now, it wasn't burned off, all worn and everything like this one, but it just had a little piece of something stuck. And it seems like it would blow out of there, but it doesn't. You just break it out of there with your little pocket screwdriver, and you put the plug back in. Of course, I usually pull the cord and make sure it puffs anything and hopefully blows out any trash that may be in there. But anyway, you'll see one like that sometimes, and that's obviously going to be a problem. All right, sometimes if you got a hose rubbing against another hose, you got a potential here. You need to be paying attention, obviously, to whether these are rubbing against brackets or anything. But even if it's rubbing against another piece of rubber hose, you can have a potential issue here, and that's something you need to be paying attention to, because that can cause a real problem right there. This is a New York vehicle. You guys that work in those northern places, you can have your rust, man. We don't do rust down here, okay? I'm not saying the bodies don't rust on any of our vehicles, but when we look under there, we don't have rust. And it's got to be, occasionally we'll see brake lines that are rusty, like I was talking about last week. If you see actually week before last, if you see a brake line that's laying in there where the mud's caked up around it, you may see that. But this business of salt on the roads down here, we don't have ice on the roads, and we don't have to salt the roads, and so we don't have the kind of rust that you guys have. Man, I just feel for you characters. We would get one like this every now and then down here, and we had to do all that rust work and everything. Of course, in Port Arthur, if there was a truck that worked on the coke dock over there where all that coal dust was, you would literally have to air hammer all of the stuff out of the way to get to the bolts to take the transmission, cross member out, this kind of thing. So everybody's got their own stuff that they got to do, but that was one right there. That was an Impala that we looked at. Though on a different Impala, this one right here, this spark plug here, you can see all that gray, dusty, musty stuff. That thing had danced around enough on that Impala to where it blew the spark plug out. And I don't know how many miles it took for that thing to screw itself out, but that's the original plug. And that thing had a lot of miles on it. I can't remember how many miles it had on it, but it was up around 100,000 or more. And that spark plug was the one that came in the car, because that vehicle was bought while I was at the college, and nobody ever put plugs in it anywhere, because we did all work on it over at the shop. And whenever that thing blew a plug out, it really, really surprised me that it had screwed itself out and come out of there. I don't know if it wasn't tight to begin with or whatever, but it was also the one that was on the corners of the engine back there where the passenger is and all that. So I ain't gonna try to even remember what number that was, but it's the one farthest toward the passenger's corner of the engine on the back, and it was a booger bear. These punctures are too close together to be, somebody plugged them, you know, but if they're that close together, you're not really supposed to plug them. But the fact is that tire's wore out anyway, so why not just throw it away? I'm not saying it's going to leak again, but the tire people say if it's got more than a certain number of holes in the tire, you're not supposed to fix it. You're supposed to replace it. If these holes are too close together, you're not supposed to fix it. You're supposed to replace it. And there's just these rules that, you know, a lot of the times people that do tires don't worry about that kind of thing. If somebody's in a bind and they need a plug put in there, or you ever put a plug in a tire out there in a parking lot, it's a workout, you know. All right. Now this right here, you got a high heat. This is a plug that looks like you expect it to do. And you see one like this, you think, oh, there's something nasty going on right there. That's oil deposit. It's a lot of heat too. That's pretty hot, you know, because it looks like it's either got real heavy deposits or it has begun to crack that. That was some plugs we pulled out of something. I don't remember what it was, but I just zoomed in on that and give you a picture of it. We did a 99 Expedition engine swap. And whenever the lady brought the engine for us to put in her Expedition, because she had, you know, screwed the engine up in it anyway, she brought an engine from a Lincoln. Okay, now that was okay. We made it work. But you notice on the Expedition they had more grooves in the belt. This is the power steering pump off the Lincoln engine, and this is the pulley off of her original engine. This is the idler pulley, and you know, you can tell the difference in the width of that. But we actually cobbled all that together and made it work. You can actually use just some of the grooves. If you've got a narrower pulley down here, you got to use a belt that will work with this one, and make sure you line everything up right. And you can basically just use the narrower belt, and you'll see some exposed grooves, which may confuse people if they're not aware of what's going on. This definitely needs attention. When you see something like that, you don't need to just ignore that, because there's liable to be problems later. It's obviously seeping a little antifreeze, and it's giving you that chalky stuff right there. You might remember on my 2006 Explorer, I have a metal one of these that I bought from Parts Geek. And the metal one I bought from Parts Geek didn't cost any more than the plastic one you buy from the parts store. Now, it didn't come with the temperature sensor, but that's okay. There was nothing wrong with the temperature sensor I had, and I just put it in my new metal one that came from Parts Geek. Now, I will tell you, the one that came from Parts Geek, I did have to do a little grinder work on it so that it wouldn't interfere with one of the brackets, but that didn't hurt anything. And so now I got the metal one on there. They send you a nice red silicone hose. But you might not have known it, but silicone, over a period of time, will actually weep coolant through the hose more than regular rubber hose will, which I thought that was interesting. Police cars typically come with silicone hoses on them because of the heat factor and all that kind of thing. But anyway, all right, doing one crucial thing wrong. My dad's Grand Marquis, this student of mine, put a hood release cable on it, and he did everything right except he didn't pop that grommet in there. And so the first time it came a rain, my dad says, I've got water in the floorboard of my car and I've never had it before. So I had him bring it back down there, and we found this grommet out of place, and the thing was fixed so that when it rains, the water would follow this down here, just go right in the car. So we had to basically pop that grommet back in place, and that took care of that problem entirely. Now, I told the student, I said, don't make this mistake again. When you're putting that in there, even if everything works right, if you put it in there on a dry day, they won't know they have a leak until later on whenever it comes to rain, and that's a disaster. Now, soldering, well, this student is still learning how to solder, but what I like to do is I like to make sure that soldering iron, I didn't have pencil soldering irons for them because that one left on. So I would have a trigger pull soldering iron, And I like to get that hot enough. What I like to do, and this guy's not doing that, is I like to, and this really needs to be clamped better. That's my little homemade tool. It's got a loop of wire with 2 clamps on it. And I would take that and I would basically stick the tip to the wire, and then I'd let the solder touch the tip and the wire at the same time so that it would wick all the way through and you'd have a really good clean solder joint there. But these things right here act as a heat sink. If you got your heat shrink tubing over here, you know, the heat is liable to be, it'll be captured by these before it'll go over here and shrink your tubing so that you can't get it back over the thing. Anyway, soldering well is something that every mechanic needs to know how to do. Alright, well, I want you guys to have a Merry Christmas, and I appreciate you tuning in for the video. Hope you got something out of this, and I'll be talking to y'all next time.